Hello, my name is Langston Key, and this is my project on Raymarching. Raymarching is a 3D graphics rendering method. You may have heard some other methods, such as rasterization, ray tracing, or path tracing, but essentially they all have the same purpose of displaying three-dimensional objects on a 2D screen. But why would we do ray marching? We already have a 3D rendering method that we use in Unity. It's rasterization. However, there is some cool advantages of using ray marching. It has soft shadows and ambient occlusion basically for free, and it's a really intuitive way of doing reflection and refraction, as well as a ton of other cool stuff. So how do we do it? I use this tutorial by PurePlay, but there's a ton of other great videos explaining the conceptual reasoning behind ray marching that you can look up. But in general, it works like this. The big idea of ray marching is shooting a ray for every pixel on the screen and then figuring out whether or not this ray is colored in or not colored in. Once we have the distance field, we're able to tell where the camera is relative to another shape in the scene. And this tells our ray that we're shooting out from the camera how far it's okay to go without intersecting. We can continue this process of checking the distance field and then marching until we get to a point where our distance is so tiny that we have to be hitting an object. Of course, sometimes rays won't hit objects, and in those cases, we have a maximum distance that the ray can go before we essentially delete it and say, okay, this is just going to be blank space. So first, let's go through our Unity implementation before we get to the crazy geometry. We start by just drawing a quad in front of the camera. So the next thing we want to do is pass in information about the camera frustum to the shader. And the camera frustum tells us information like the field of view, where the camera is, and as well as the aspect ratio. And we need all of this information if we're going to shoot rays in the correct direction. And next we're going to make an image effect shader in HLSL. So the most important part of this shader, a lot of it is boilerplate. We really just are focusing on the fragment shader. First thing we're going to do is pass the ray from the camera into the fragment shader. So next, this is our actual ray marching method. We start by defining our array origin, which is like where the camera is, our ray direction, depth we're skipping for now, the max distance and max iteration. So it's like how many marches will this ray take and how far does it have to go until we can be like, okay, this is far enough, we don't have to draw any shapes. So this is the first thing we're doing, is we're actually checking to see if it goes too far, and then we're going to break early. So we don't need to do as many iterations if it is already passing the maximum distance. And next we're going to check for hits, so those are like misses, and then we check to see if the distance is really, really, really small, then that means we probably hit an object. Now we are to our fragment shader, so we're going to go ahead and use this bool to determine whether something on the screen is hit, in which case it's white, and if it's not hit, then it's black. Let's paint a sphere on our mathematical canvas, and this is one of the most elegant things about ray marching. Shapes can be very beautifully described in simple ways. So a sphere is literally just a length minus a radius. Yay! Okay, that's super cool. We have a black screen and a white sphere. So this is ray marching, but we can get a lot cooler than this. So let's keep adding some more. First, let's make the scene visible. Next, we're going to get the normal. And the way we do this is a little different from the way vertices work, because vertices kind of naturally have that data within them. So we have to do what's called a gradient. And that basically just takes the values on a 2D plane and estimates it from there. And from that, we're able to get, with the light direction as well as the normal, a classic Lambertian diffuse. So there you go. We have a hard lit base Lambertian diffuse, but we're kind of back to normal Unity. Like this just looks like a normal Unity sphere. So let's do some interesting ray marching unique stuff in addition to just this normal Lambertian diffuse that you can also make with ray marching. So with these, you can make shapes like this, and if you can see, those methods are tiny. Like you can make some crazy shapes with like 3 lines of code. So that's one really cool thing you can do with Raymarching. Also, you can visualize math operations. So this is modulo, like the operator p mod x basically makes it so that you can see with one evaluation of the shape, infinite shapes going off in the x-axis. And if you were thinking about this, you can do it in not only 2 dimensions, but 3. And these 3D infinite spaces are really trippy and cool to just experience and fly through. They're really interesting to change, and the best part is you can actually change them in real time. In addition to this infinite geometry, we can also upgrade the appearance of our shapes from a normal Lambertian diffuse to something a little bit more fancy. Using soft shadows and ambient occlusion, we can turn the ray, which always knows the estimated distance between it and the shapes, into information. So additionally, reflections work the same exact way as they do with the camera, but instead of shooting rays from the camera, they shoot rays from where it hits the object. So where it hits the object, we'll shoot another ray, and it may bounce up another object, it may bounce onto the sky, in which case we need actually a cube map to draw onto the screen instead. With that, that is the conclusion of my Raymarching exploration. But where do I go from here? So for the more creative aspect of this project, I'd really like to explore 3-dimensional fractals, which I think could look really beautiful, and also collisions. So all this beautiful geometry is awesome to look at, but by default, it's completely uninteractable by normal Unity physics or any other physics for that matter. So wouldn't it be awesome? Hypothetically, you have the distance from everything to everything, so you should be able to figure out collisions somehow through that. But yeah, thanks for listening to my presentation on Raymarching, and I really hope you check out some Raymarching videos on YouTube because there's some beautiful math out there.